This is the second part of polar equations for conics. I am continuing from the same example as I did in part 1, but I want to come back and emphasize what we need to focus. Number 1, we need this to be a 1. Whatever that number is, divide by it. Top, and literally divide that number to every single term. Top, divide here and also here, just like what I have here. This must be a 1. So whatever that number is, divide to the top, divide to itself, and divide to the right side, just like what I have here. So that's the first thing. Second thing, find what is E. E will determine ellipse, hyperbola, or parabola, just like what I have here. Okay, E will determine ellipse, parabola, or a hyperbola. Okay, and with ellipse and hyperbola, you have to use E equals C over A. This will help you to find A, C, and also B. Okay, so the problem we have earlier, this was the problem. Okay, now once we identify this, rewrite this into this, and identify the ellipse, whatever the conic is. Now use these 4 degrees, 0, 90, 180, 270. Always use these 4 degrees so that I can get my points. Okay, here's my first point, second, third, and fourth. Okay, also because it's facing to the right, my directrix is on the left side. Because it's facing to the right, my directrix is on the left side. So that's why it's negative. D is the distance from the directrix to the polar axis. This is my axis right here. Okay. Now, because this is horizontal, your major axis is from left to right. Minor is from top to bottom. If this was vertical, then just reverse the major and minor axis. Just reverse it. Okay. And the third thing we need to find out, well, this is the third thing, is to use these degrees so that I can get my points, so that I can graph. Okay. Next, we need to find out what A is, what is B, what is C. What is the distance from A? What is the distance from B? What is the distance from C? Okay. So be very careful of that, which I did it in the last video. Okay. Now with ellipse, there are 2 focus, one on the left and one on the right. To get these points, it is the distance of C from the center to the left, which is the distance of C. How do we know C? Which we have it right here. Here's C. Here is C, which is 2. Okay. And I did show you this from last video. Okay. So distance from center to the left, which is 2, first focus. Distance to the right, which is the second focus. Center to the vertex, that's my distance A. Center to the upper vertex, which is my distance B. Okay. Now what I have here is just a rough estimate. It is not an exact graph. So let me go on to the next page. I hope this helps you out a little bit more, where this is a better graph. Okay. A very perfect graph. Okay. More accurate and precise. So here is one. Here, if you remember these points, here, here, and also here. This point, this point, this point, and this point right here, which is from the 0, 90, 180, 270. Okay. So here's my center. Here's my A. A is from vertex to the center. The distance of A is from the vertex to the center. That is A. So from here to here is A. From the top vertex to the center, that is my B distance. And from the center, 2 units to the left, which is the C distance. The C distance, the distance of C will determine my focus on the left and the focus on the right. One more time. The distance A, center to here. Distance B, center to here. Okay? Now, the distance of C will help you to find the focus. For center to the left, focus 1. Center to the right, focus 2. Because the distance of C is 2 units, so 1, 2. to the left, 1, 2 to the right. Okay, so this is my major axis from left to right, my minor axis top to bottom, again because this is a horizontal. Okay, and if you kind of imagine, I forgot to put in the directrix is on this side, because here I only have to -4, but directrix was all the way up to -6, so I forgot to put the directrix here. Okay, so if you look back our graph here, I've just forgot to put the directrix. Okay, all right, so that's what it looks like to be a more precise graph. Now what I have here is a rectangular graph using a rectangular coordinates. Okay, rectangular coordinates. I will explain to you where did I get this equation from. Okay, so here is the polar form. Here's the polar graph. Okay, so rectangular graph, polar graph, it is the same graph. Okay, again, rectangular graph is on top, polar graph is in the bottom. It is the same graph. Okay, just that the top is in rectangular form, the bottom is in polar form. It is the same thing. Okay, so again, rectangular, polar, same graph. Okay, just that this on top is in rectangular form, this is in polar form. Okay, same equations, same graph, just different way of writing the equation. Okay, again, same graph, different way of writing the equation. This is polar equation, this is rectangular equation, and I will explain to you where did I get this equation from. Okay, how do I get this equation? Rectangular equations. Okay, so I hope this graph is a better version of this so that you can see a little bit better. Okay, again, what I have here is just a rough estimate. This is a more better graph. Okay, so that is the main purpose, is to find what kind of conics it is. Make sure that this is a 1 right here. Make sure that it's a 1. Again, the main purpose is to identify what kind of conics. After that, always use these degrees to get my points. Okay, after that, find out my A, find out my C, find out my B. Okay, if it's an ellipse or a hyperbola, you have to find A, C, and B. Okay, and that's what the graph looks like. Again, this is horizontal. Okay, directrix is on the left side. Okay, now sometimes this can also be vertical, so it depends. Okay, so if you remember, the general graph right here, minus, right here, minus, here's minus, face right, plus, face left. Okay, minus sign, face up, plus sign, face down. Okay, so those are the general form, so be careful when you do this. Okay, and I hope this graph here is a better version of this. It's the same thing, it's just this is approximate, this is a perfect graph. Okay, now how do I get this equation? Where did I get this equation? How did I get this equation? Okay, so our next objective is to convert polar equation into rectangular equations. Polar equations into rectangular equations. Okay, so 3 things we need to have is our center, our A, and our B. According to a graph, our center is right here, which is 2, 0. Okay, our center is 2, 0. The distance of A is from here to here, which is 4. The distance of B from center up, which is B to square root 3. Okay, so we have our center, we have our A, we have our B. Okay, so now with rectangular equations, we have this form, x minus h, and we know that this form is for ellipse. Okay, for ellipse, we use this formula. Okay, for ellipse, we use this formula. So x minus h square, a square all over a square, plus, and then y minus k square all over b square equal 1. Okay, so this equation is for ellipse. Okay, again, this equation is for ellipse. Okay, So we have our center, we have our A, we have our B. So just plug them in. This right here is my X, this right here is my X, but we're going to pretend that this is H and this is my K. Okay, so whatever this is, just plug it in. Plug 2 in, plug 2 in, which one I have right here. Plug 2 in, which I have right here. Here's my K, K is 0, which I have right here. Okay, my A is 4, so make sure, don't forget the square. My B is 2 square root 3, don't forget the square. Okay, don't forget the square. Okay, so again, this right here is my H. Okay, this is my K, so H, K, okay, my A here, my B is here. One more time, H is here, K is here, A is here, B is here. Where did I get this formula? This formula is for ellipse, okay? This formula is ellipse, okay? So just basic math here. So x minus 2 squared, so there's nothing to do, leave that alone. You know that 4 squared is 16. Now y subtract 0 is just y, so y squared. Now 2 square root 3 to the second power, 2 square root 3 to the second power. So here's the basic math over here. Okay, just basic algebra. Factor that square to the 2, factor the square to the square root 3. So 2 squared gives me 4. Square root and square, that disappears, so I just have 3. So 4 times 3 is 12. Okay, so there's my A squared, there's my B squared. So this equation is rectangular form. This equation, rectangular form. Both of these equations are the same graph, just written in different format, just like what I have here in the graph. Okay, both of these equations are the same graph. One of them is in rectangular, the other is in polar. Okay, so again, these two equations are same graph, just that this is in rectangular form, this is in polar form. Okay, so that's how you convert polar to rectangular. But be very careful. Remember that this equation is for ellipse. Okay, so this is the part 2.